If a particle undergoes a simple harmonic motion with amplitude 0.19 meters, what is the total distance it travels in one period? Express your answer to two significant figures and include the appropriate units. D is equal to question mark. Obviously, this question is based on simple harmonic motion. Now, let us study what is the simple harmonic motion. A periodic motion, you know a periodic motion. A periodic, I will show you. Suppose, let us consider this be the simple pendulum. Okay, so the simple pendulum consists of an inextensible string attached to a metal sphere, and this is called the bob. Okay, and suppose if we pull the bob to one end and then release, then this is the initial position. From initial position, it crosses the equilibrium position and reaches the other extreme. And from other extreme, it crosses the equilibrium position and comes back to the original position. Entire journey is called one oscillation. Starting point to equilibrium position to the other end, again equilibrium position to the starting point. This is the end. Okay, so this total journey is called one oscillation. Okay, one oscillation. And then time to complete one oscillation is called one period. Time to complete one oscillation is called time period. He is asking us to find out one time period. Okay, so now from the equilibrium position to the extreme position is called the amplitude. That is the maximum displacement. So maximum displacement from the equilibrium position, is called amplitude. Is called amplitude. You may be wondering, we have two ends. What about the other end? Both are amplitude only. Generally, according to sign convention, we will take right side as positive and left side as negative. So suppose if this is A and this is minus A. So we represent amplitude as plus A and minus A. Okay, so this is right hand side is called plus A plus amplitude, left hand side as minus amplitude, negative amplitude. Okay. Now, what he is saying, if a particle undergoes simple harmonic motion, now we will have to describe what is simple harmonic motion. Here, the pendulum is in equilibrium position. This is the equilibrium position. Okay, this is the equilibrium position or rest position. When we apply the force, that means pulling. When you pull the bob to the extreme position, then this is the amplitude. So because of the application of the force, the object has been displaced. Okay, and then the force and the displacement are in the same direction. So this is the direction of the force. Am I right? And then the displacement is also in the same direction. When you leave the bob should rest here itself. It should not move further because no force is acting on the system. Therefore, the object should be at rest. But here what is happening, the moment we leave the bob comes back to the equilibrium position. So how this is happening? This is happening because of the force called the restoring force, which is inherent in the system. So that force is pulling the bob to the equilibrium position. Okay. So that force and the displacement are oppositely directed. The restoring force is in this direction, or the restoring force is pulling the object in the opposite direction. Am I right? Here in the first case, when we apply the force and displacement both are in the same direction. Am I right? So next, what is happening from here? The force is trying to bring the object back to the equilibrium position. So the force is acting in an opposite direction to the displacement. Am I right? Initially, the displace as it is going in this direction, immediately the restoring force starts acting. Okay, so at this position, the restoring force is maximum. Therefore, F is proportional to the displacement. That is, the displacement is represented by X. F is the restoring force. F is the restoring force, and X is the displacement. And the negative sign indicates both are oppositely directed. Okay, therefore, F is equal to minus Kx, where K is the force constant. Okay, now what is this amount of force? This force is nothing but your mg, mass and gravity mg. Okay, so F is nothing but your mg. Mg is proportional to, or mg is equal to minus kx. Or if this is the acceleration due to gravity, g is the acceleration due to gravity. Or you can write acceleration also, acceleration due to gravity here. Or you can take sometimes, or you can take MA, since you know F is equal to MA. Therefore, MA is equal to minus KX, or A is equal to minus K by M times X, where K by M is the constant, or A is equal to minus omega square X. Okay, instead of K by M, I write omega squared. Okay, therefore, this is the condition for the simple harmonic motion. What is the condition? The acceleration and displacement are oppositely directed. Understood? So whenever an object is in periodic motion, in which the acceleration is always directed towards the, our acceleration and displacement are directly proportional to each other and are oppositely directed, then it is called the simple harmonic motion. So simple harmonic motion is a special case of oscillatory motion or periodic motion. Okay. In periodic motion, if the acceleration and the displacement are directly proportional to each other and are oppositely directed, then it is called the simple harmonic motion. Okay. Now here in the simple harmonic motion, he gave amplitude as 0.19 meters. So this distance is 0.19 meters, and he is asking us to find out the total distance it travels in one period. So in one period, it will travel from, this is the maximum now. So we pull the bob to one extreme. So from this extreme to equilibrium position, so this distance is 0.19 meters, and again 0.19 meters, and coming back 0.19 and going back to 0.19. So total 0.19 times 4, that is equal to 0.76 meters is the total distance traveled. So the d value is equal to 0.76 meters per 0.76 meters is the answer for this question. Understood? This is based on the simple harmonic motion. If you know what is one period and how much distance it travels is initial position to equilibrium position, and next other end, uh, maximum displacement, and then other extreme to equilibrium position, and then back to the original position. This one cycle is called the one period. Okay. In this, it is traveling this much of distance. Okay. Hope this helps. Thank you. Bye bye.